Okay, welcome to week 8. You are halfway done. Can I get a check on my sound? I had a disaster Monday. We actually couldn't even finish class. The webcam was not working. The sound went out. So can somebody say, can they hear me? Hello?
Yeah, I can hear you.
I can hear you.
Okay,
I can hear you.
you about gave me a heart attack for a minute when I didn't hear anybody again. Everything went down Monday. So we are up and running. You got the screenshot. So we are good to go. Not much new. Should have your test appointments made, hopefully, to get the time you want in week 10. Project 2 was assigned last week. Hopefully you printed all 3 sheets. Remember, it's 2 Excel documents and 1 Word document. Make sure on your Vampire appliance, I reminded you last week, use non-usage hours. I already had one person turn it in with their usage hours. Make sure, remember, it's on a different page, the non-usage hours. It's a different wattage. It's when it's not in use. Put it in a different section. You have to use at least 1 or 2 of those appliances. So start early on that. Make sure you don't use the same appliances as the sample. You can't use exactly the same thing. You don't have the same car, the same mileage. They will help you. It's 100 points. Get all 100 of those. And make sure you're doing everything in the modules that's out there. Don't wait till the last minute. I'm not accepting any lates anymore. I only did that in the beginning because of the technology issues with WebWorks. So discussion boards, last week's was easy. Some people just didn't do it. The Excel assignments are usually pretty easy in the weekly ones. Make sure you get those points. Any questions for me?
Oh, I was wondering, your Monday class, if like before the next exam, if you wanted to listen on that, when do you start Monday class, and how would I be able to listen to that?
Mondays is also at 1 o'clock, just like yours. And I just need to send
Okay.
out the link. I can send it to your whole class. I don't do that in the beginning because then people end up selecting the wrong class. I think you're smart enough now. You know how to get to this class. I can send it in an email to all of you. This is the link to
Okay.
the Monday class because it's a good idea to do that. Um, I think for all of you, if you've got it in your schedule that you can come on Monday, it's a much smarter time to do it. Test week to come on Monday, then that gives you more time to study, even if you're taking the test on a Thursday. Um, if you get the review done on a Monday, you can keep going over it and over it. So I can send the link out with here's the code to the Monday class. I can do that this week. Um, I just hate to do it in the beginning because then people end up
Taking the wrong class.
in the wrong class and they don't know what they're doing initially. But I think you guys know how to get to the right class now. So
Yeah.
I can send that out to you guys, the link for the Monday class. Good question. Okay. I can send that out to all of you. And that's also if you need to be absent, sometime and you just want to come to the Monday instead because you got something on a Wednesday, that's fine too.
Okay.
Okay.
Thank you.
Okay. Anybody else? But especially during test weeks. That's a good plan to have. Or you can come to more than one review. That's fine too. Okay. This week is all about the normal curve, types of distributions, and probability associated with distributions. So if you've had statistics, you may already have had a lot of this, been familiar with it. This kind of jumps into mid-level statistics without doing the beginning. So I kind of just have to fill in the blanks the best I can. Jumping into z-scores and probability associated with z-scores without everything in the middle. Um, just follow along with what it means and how to follow the chart. And it's very real life. It's used all the time in insurance, all kinds of stuff. And the empirical rule is where we start out, also called the 68 95, 99.7 rule. Okay. Now, not all data is distributed normally. We've already talked about data distributions. Some can be skewed left, some can be skewed right, and some are symmetric, which is the normal curve, like we've talked about. Okay. In order for this rule to apply, it has to be normally distributed, which means the mean and the median have to be the same, and the data is symmetrically about it. Now, it can be flatter, like this. It can be narrower, or it can be anywhere in the middle. But it's got to be symmetric about the mean. How far it's spread out about the mean, that's what standard deviation is. That's that spread about the mean is the best way I can make it simple for you. Since they don't really go into standard deviation, they don't go in, you're never going to have to hand calculate it. They're going to let you do it in Excel. There's an FX button. There's a quick, easy FX equals. It lets you do it. You're going to need to do it in the homework. You're going to have to bring up Excel and do it. Find the standard deviation. You've already done the mean, median. I don't think you've done standard deviation, but there's a quick button to do that. In the previous course that this was modified from, you spent a lot of time understanding what standard deviation is and how to calculate it by hand, taking all the data points, finding the difference, how far they were from the mean, adding them together, square rooting them. They don't even go into what it is, just understand it. What it gives you is how far spread it out. The more the standard deviation is, the higher, the more spread out it is, the more flat. The smaller it is, the closer they are about the mean. So good news for you on the calculation part, but I would prefer you understood it a little more. So knowing you're given that it's normal, the empirical rule is an estimate. It's not as accurate as doing a z-table and finding the probability. This is an estimate, and it's a very good estimate and a quick way to find some information out about normally distributed data. What it tells us is, if you know it's normally distributed and you know the mean and you know the standard deviation, 68% of your data is going to lie plus and minus one standard deviation from the mean. Okay, so let's take some easy numbers. Let's say your mean is 50 and you're given that your standard deviation is 5. Okay, you're either going to be given this information or have to calculate, but you're going to have to know the mean and the standard deviation. If it's normally distributed, there's a lot you can figure out, percents, probabilities, where your data is going to lie. What this rule tells us, we would put the mean right here in the middle of our bell curve, 50. Okay. What this rule tells us, that 68% of our data, no matter how much it was, if it was 10,000 entries, if it was 50 entries, it should be over 35, a large entry, that 68% is going to lie plus and minus one standard deviation. So if we add 5 and subtract 5, 68% of our data values are going to be in the range from 45 to 55 if our mean is 50 and our standard deviation is 5. And because it's symmetric, that means 34% will be from 50 to 55 and 34% would be 45 to 50. Okay? Now, these can be any numbers that are given, but I don't want you to confuse. The plus and minus 1 are not the number 1. It's one of whatever the standard deviation is from the mean. Okay? So then if you go one more partition, one more standard deviation, and in this case we'd add 5 again, this would go up to 60, and a 40, this rule tells us that we can expect 95% of our data to lie within that range. Okay. And this rule tells us if we go one more, which would be 35 to 65, 99.7% of our data values will lie within that range. Okay. Now, a lot of things are determined by that. And again, the breakdown symmetrically. So since plus and minus 2 adds up to 95%, that would leave 13.5 in each of these segments because they're symmetric, so that this entire portion adds up to 95%. If we go one more, each of these segments has to be 2.35%. And this outlier right here, it's not 15, it's 0.15%. Okay? Less than 0.2% are in this outlying region. And why do we know that? Because the entire area under the curve is 100%. The probability has to add up to 100%. Okay, very important. Probability must sum 100%. Now, it's symmetric. So this half is 50, this half is 50. Okay? Making sense? Hopefully you've looked at this already. Okay? Okay, so let's look at some of your questions here. The first ones are just asking about the setup here. Anybody questions on 1, 2, 3, 4? Okay, let's look at 5. The distribution of heights of adult men in the U.S. is approximately normal, with men 69 inches, and standard deviation of 2.5, or the mean, inches. Use what you know about the normal empirical rule to answer the following. This is telling you how to enter it. About what percent of men are between 64 and 66.5 inches? Okay, so my suggestion is each time you draw your curve, we start out with the 69 is our mean. We go plus and minus 1, 2, and 3 standard deviations. Okay. So if we add 2.5, get 71.5, 74, 76.5. Does everybody see what I'm doing? I'm adding plus 1, 2, and 3 standard deviations. Then I'm subtracting 1, 2, and 3 standard deviations. Okay. Now we're going to apply our rule. 68, 95, and 99.7% rule. Okay. 68% lie within this range. Okay. And back to our chart, which you will have to know. You can figure it out with the math, but you can also memorize it. It's symmetrical. Okay. That means this is 34% in this two partitions. 95% are within 2. That gives us 13.5 in these parts. And 99.7 would fall in this range, leaving us, actually our book uses 2.35, not 2.4. And on the tails, we have the 0.15. Now you can answer the questions. Okay. Questions on that, on making the chart?
Could you put your paper a little bit down? It's cut off a bit.
This one? Up?
Yeah.
Okay.
Thank you.
Okay. Then our question A said, what percent of men are between 64 and 66.5 inches?
95%. Is that right?
You're just looking at these, between these two amounts. So we're just going from here to here. What's that percentage just between these two?
13.
Yep,
Okay.
13.5. $69 and $74 would be what? So what have I got to add together? This one and this one, right?
Mm-hmm.
So I'd get
47.5.
Yep, 47.5. And C asked me taller than 74 inches. So what would I add together for that?
What was the question? Sorry.
Taller than 74 inches.
Oh. 2.5.
Yep, 2.5%. Now, one of the questions you'll be asked a lot on the test would just be like, what would be the range? Where would 95% of my data lie? What if you were asked that question? What would be the range where 95% of my data would lie? Between what and what?
So you'd have to add together 13.5, 39, 13.5.
That would give us back the 95. It's asking the other way around. What would the data be? What would the range of the data be? We already know the 95%. I'm asking the reverse question because you're going to get that a lot. What would the range of the data be that would 95% of your data would fall in? 64 to 74 inches. Okay. What would the range be for 68% of your data would fall in? 66.5 to 71.5 inches. And
Okay.
what would the range would 99.7% of your data fall in? It would be 61.5 to 76.5.
Okay.
Because you will get asked that version of the question as much as finding the percents is finding, given the percent, what's the range of data? Okay. Okay. This one's a little easier to see. Okay. The price earning ratio of a sample has a mean of 11.5 and a standard deviation of 2.7. If they are bell-shaped, meaning the normal curve, so I would go ahead and make it. Then they're going to ask you the question. So what goes in the center?
The mean.
11.5. And then we're going to take the standard deviation, 11.5 plus 2.7. That's 14.2 plus 2.7.
Mm.
16.9 plus 2.7, 19.6. Now we take it and subtract. Okay. So what percent of our data is between 8.8 and 14.2? What does our rule tell us? That's
68%.
Yep, 68. That's plus and minus one
Yeah.
standard deviation, so that's 68%. 34, 34. That's one standard deviation above and below. 6.1 to 16.9. They're making these easy. 95, right? Because that's plus and minus two standard deviations. Shouldn't have to add those together, because if it's plus and minus 1 is 68%, plus and minus 2, 95, plus and minus 3, 99.7.
7.
Yep, that's it. You got it. Okay. Now, I already put this in Excel, but the technology that happened, my whole computer crashed and everything on Monday. Let's see here. On this, you're going to have to use Excel. Okay, I brought up Excel for you there. Just to show you real quick, I'm not going to put in all these numbers. Let's just say I had 10. And I wanted to find the standard deviation. If I go to the automatic ones here, and you type in standard deviation, right there's what you want. you want that one right there. Then make sure you get the right things you want. Like I have those three, C2 to C5. So I'd change that to a 5. Oops, didn't want to do that. Let's come up here and grab those. Okay. C2 to C4. And there's my standard deviation. Okay. Everybody see how easy it is to get standard deviation? Okay. That's one extra thing you're going to have to do in Excel to find these out. And again, those weren't those numbers. Okay. But this is just back to finding, mean, median, and mode. You've done the projects. You're just going to have to put in the data and find the standard deviation. Same thing on this one. And then on this one, you're finding the mean, standard deviation, and then using the rule. So we'll go ahead and we know the mean. Yours will be different than mine. Is 98.9. The standard deviation is 0.7. I said you're going to have to put it in Excel. Okay. So these are temperatures, and it's saying calculate the mean and standard deviation using Excel, and here's the numbers. Use the empirical rule. Find the probability of a body temperature being less than 103. Okay, so we start out with 98.9. So we would add 0.7. This would be 99.6. I really don't need to fill in all the rest of them. This is the one we desire. Okay. And it's saying less than, so we want this entire area from here down, right? Well, what is half? If the whole thing probability is 100, what is this whole half without adding each part?
50.
50. So that's 50%. We know this segment is 34, right? Have you already memorized this part is?
And 13.5.
So all we have to do is 50 plus 34 plus 13.5. So a 97.5, and they say I've got it wrong. They say I've got it wrong. Oh, that's the answer for the temperature. What have they got? Yes, that's what they've got. 0.975. Supposed to enter it as a decimal. Okay. Another way you could have done it was 100 minus these two parts. Right? Wouldn't that make sense too? Different ways you could have got it. Okay. Questions on that one? You understand the empirical rule?
Yes, ma'am.
The empirical rule is an estimate. Somebody have a question? Okay, I got one quiz question for you on the empirical rule. The rest look like they're Z-scores. Two quiz questions. Okay, here's your practice question. Here's a quiz question. Let's see how you do on it. Try number 2. Okay. Does everybody know why I drew this diagram?
Because it's nice to have a visual.
And it's the empirical rule. They gave us the mean, the standard deviation. They said it was normal. So I put 84 in the center. I did plus and minus 3 standard deviations, and our rule tells us 68% are plus and minus 1. 95% are plus and minus 2. And 99.7 are plus and minus 3 standard deviations from the mean. So that will answer our questions for us. So what's the answer for the first part? 68% of her scores would be between what two values?
76 and 92.
Yep. Yeah. Everybody going to get that on the test?
Hopefully.
99.7%. Some books use 99.5. So 99.7 would lie where? Between 60 and, if I did my math right, tell me if I made a mistake. Anybody get the same thing? Questions?
Oh, yes. Oh, not a question, just yes to
You
your.
got it? Okay.
Yeah.
Ashley, you good? I haven't heard from you. You got it? Ashley, okay? Question? Deontay?
Yeah, I'm good. I got it.
Okay, try the next one. Thought I saw 2 of them on here. Yeah, I think these are all z-scores. Okay, all the rest are z-scores. Okay, so we have to look at the next section before we can do that.
Okay.
Okay, now, remember I said this was a quick estimate? So we were looking at probability earlier. Probability between some things. Like we added up all these. This is fine and dandy for if we're lying on plus or minus 1, 2, or 3. But what if we wanted to know the probability of something in the middle here or this way? This rule won't do us much good, okay? Because it only tells us the amounts for each partition. If we're not on plus or minus 1, 2, 3 or standard deviations, let's say we wanted to know the probability of a 97.5 this way or that way. We don't have an amount for that. You can't just split these because it's a curve. It's not an equal amount. Okay? This rule won't work for that. Okay? We need something a little more sophisticated. And that's where the z-score and your probability tables come from. And that's where you need this z-table that will be provided for you. So to find a z-score, what a z-score is, you're finding how many standard deviations a data value is from the mean. Then you have a table that will give you the probability of being less, area below, less than where that is. So if you had a probability of a z-score of 0, it's going to be 50% because it's the area under the curve below. Okay? If you had a z-score of a -1 right here, then it's the probability always below. It's the probability of the area under the curve down here. Now, it's not going to add up to exactly what these add up because this is more accurate. Okay? But it's close. And this would be, the probability down here would be a z-score of 2. Now, if you have to find the probability of above, you have to do 1 minus it, because remember, this is 100%. And this table, and you need to make a note, z-score probabilities are always the probability of being below, less, area to the left of the curve. Okay, so it's always this direction. Okay, so first let's just do some z-scores. And our formula, it's on your formula sheet, but it's given in symbols. What x means is it's your data value you're considering minus the mean divided by the standard deviation. Okay, it's a very simple formula. It's telling you how many standard deviations you are from the mean. So the first question just says there's a random variable with a normal distribution. This is mu, that's the mean. This stands for the mean of 21. And this is the standard deviation symbol, and it is 9.7. Okay? Z-score, you always put the data value first. So this is, consider this data value 22 minus the mean 21, and then you divide by the standard deviation. So it's a simple calculator problem. Remember, for order of operation, you have to do the numerator first. 22 minus 21, well, you shouldn't have needed a calculator. I was just 1 divided by 9.7. You get 0.103, round to the hundredths. So we just have 0.1. Okay? Anytime you're above the mean, it's going to be positive. Anytime your data value is below the mean, it's going to be negative z-score. If it's the same as the mean, it is 0. Okay? 22 is above the mean, so it's positive. Okay? Let's look at 19, C. We'd go z equals 19 minus the mean, 21, divided by 9.7. Negative 2 divided by 9.7. We get negative 2.206. And we're rounding to the hundredth, so negative 0.21. Okay? Z-score makes sense? That means if we were to draw it on C, here's the mean. Here's 1 standard deviation below, 2 standard deviations below. That data value would be right in here, just slightly past 2 standard deviations below the mean. Okay.
Now I have a question.
Yeah.
So for A, the Z equal 0.1, but on the probability chart, I don't see anything saying 0.1.
Okay,
How
it didn't ask us for probability, but right here is 0.1. Here's the z-score of 0.1 right here. See it?
oh my goodness. Yeah, I'm sorry.
And sometimes you won't have it, what you're looking for. You'd have to go to the nearest, just like rounding which one is it closest to. Okay?
Okay.
Because there are going to be times you won't have exactly what yours comes out to. Let's say you had a 0.8, like over here, negative 0.83. Okay, then you're between these two. Okay, then you just go to the nearest one. We don't make you extrapolate it or get into any more detail. You just go to the nearest one. Okay,
Okay.
good question. Okay, but this one is just saying what's the z-score. Now we're going to go to one that takes the z-score and asks you to find the probability associated with it. Okay, so on number 2 here, it says x is normally distributed. They gave you the mean. They gave you the standard deviation. What is the probability that a given data value is less than 130.8? So they're asking you to consider 130.8 and find the probability of being less than 130.8. Okay? So in order to find the probability, we need to find the z-score first. Z equals, we need our data value first. Common error, people put the mean first. Minus the mean divided by 28. That's 30.8 divided by 28. Okay, so our z-score is 1.1. So basically what that's telling us, this is the 100. This is 128, because there's that. 130.8 is going to come just after that right in here. Right? Just after one standard deviation. They're asking you what's the probability of being less than that. So you know it's somewhere in the neighborhood of 50 plus 34, just over 84%. It's going to be higher than 84. But the z-score is going to let us find out. So now we look at the probability associated with 1.1 on the z-table. So first we have negatives, then we have our positives. And we have 1.1 right here. And it's 0.8643. Okay, now I don't know where they told us to the thousandths place. They didn't say make it a percent, so they're probably just taking 0.864. Yep. Okay, and remember, you got to be very careful because this table always gives us less than to the left. If it said what was the probability of being higher, we would have to do 1 minus 0.864. Anytime you need to get to the right, you have to do 1 minus. Okay? Okay. This one is good just as it is because they asked for the probability of being less than something, under, below. If they asked for greater than, with the z-chart, you have to do 1 minus whatever the table tells us. Okay. Does anybody have any certain questions they want to see? Okay. Let's do number 3. A top-selling tire is rated at 70,000, which means nothing. The distance tires run and wear out is normally distributed at a mean, so there's our mean, of 70,650 miles. And standard deviation of 1,300. Okay. What is the probability that the tire will wear out before 70,000? Then it's saying round to thousandth. And B is saying probability last more than 72,730. Okay, 2 different types. Remember, our probability associated with the z-score is always to the left. So if they're saying before something, that's going to be to the left. We're going to be okay. But on this one, they're saying more than. This one, we're going to have to do 1 minus the probability on the chart. Okay? See the difference? If it's more than, they're asking for the area to the right. Okay? This one will be fine. It'll be the number on the chart. So we do the z-score, the data value, minus the mean, divided by the standard deviation, which turns out to be negative 0.5. Okay. Then we look at our chart, we find negative 0.5, and we get 0.3085. That's our probability. Round it to the thousandth, 0.309. Okay. For the second one, z equals the data value minus 70,650 divided by the 1,300, and we get 1.6. The probability associated with 1.6 is 0.9452. Okay, but that is giving us this area. They want to know what's the probability of this area. So what is left to do for our answer? We have to do 1 minus 0.9542, which equals 0.0548. So our answer is 0.055. Are you seeing the difference with less than, something below? Then it's just the probability on the chart. If it's up here, I'm sorry, I was pointing to the wrong one. If it's more than, greater than the probability to the right, you have to do 1 minus. Okay. Okay. I want to go over percentile problem. Going back to some vocabulary in a previous section, if we look at number 9, what does percentile mean? It's a rank, right?
Yeah.
you scored better than blank percent. So that's actually the percent below you. A percentile is the percent below you, right? So on our chart, it will be the area to the left, okay? So if Jenny has a grade of a 52.05, the mean was 57, the standard deviation was 5.5, her z-score, we do her data value, remember do this first, and we get okay, everybody get that far? Negative 9.9.
Yes, ma'am.
Not 9.9, negative 0.9. Okay. Now, what percentile? So we have percentile is the probability, percent that scored below you. So we look at the probability associated with negative 0.9, 0.1841. Okay, and they're reported as percents, so we'd move that decimal. She's in the 18th percentile. Okay, and they left that in the hundreds, which is unusual. Normally they just say 18th percentile, 18.41. Okay. Okay, back to some quiz questions. See if you can do number 1 for your quiz now. There we go. Okay. Type it in when you got it. This should be a quick one. They didn't ask you probability. Data value minus the mean over the standard deviation. We know it should be positive because the data value is higher. Dante and Samantha agree. Something doesn't look right there though. (82 minus 72 is 10. Are we doing the same problem?
I thought it was 1.43 because we're on to the 100. So I don't know where 71.71 is coming from, and it's scaring me.
No, you're right. I'm trying to figure out where that came from myself.
I did it all at once.
Okay, remember I kept saying you have to do this first order of operation? That's
Yeah.
because you have to do this part first or your calculator's not going to do it for you. Yeah. It'll do that division first. So, yeah, you got to do this part first, hit enter, and then do the divide by 7. And we're rounded to the hundredth, so 1.43. That's good that you did it now. Yeah. You either need to use your fraction key or do this part in parentheses or hit enter and then divide. Better now than on a test. Okay. Yeah, it would be impossible to be 71.7 standard deviations away from the mean. Okay. Okay, let's try 3. Okay. Got it that time, 1.15. Now, what percentile would that place him into? To the nearest whole percentile.
Wait, is that what you were asking for? Or?
That's
I'm not sure.
question B.
Okay.
Now B says what percentile would that be? Now this is one of those we don't have a 1.15. We have a 1.1 and a 1.2.
Oh.
So we're going to go with the 1.2, round it up to the 1.2. So that probability will be rounded the whole percentile. Okay. Percentile is those below you. You scored better than what percent of those below you? So that would be 88th percentile. Okay. Last quiz question, because this one will be missed a lot. Try to hang in there. Here's the average women's height and the standard deviation. What's the z-score for someone that is 68 inches? 68 minus 65 over the 3.5. Well, that's odd. Rounding to point. 9. Use a Z table to determine how many women out of 10,000 are taller. Okay, so what is taller, above or below?
Above.
Yes, taller is going to be above. So we're going to have to do the probability 1 minus whatever the probability on the table says, because it's the probability to the right. So we look at 0.9.
That's
0.8159. Everybody see where we got that?
yeah.
Okay, so for our probability, because it's to the right above, we have to go 1 minus 0.8159. Okay, and 68 inches is pretty tall. So yeah, it's not going to be a tall 81% chance. It's going to be an 18.41% chance. But that's not our final question. That's the probability. The question now is, how many women out of 10,000? So what's left to do? This is already decimal form, so we need to take that number times the 10,000.
Oh.
$1,841 women out of 10,000 would be expected to be taller than 68 inches. Because this would be 18.41%. You could put it in a percent and then do the part over whole equals percent over 100 proportion. But it's already decimal, so you can just take the decimal times the number. Okay. All right, any questions? Okay, make sure you're working on your projects, getting all your assignments in. The project and test 2 will be here before you know it. Keep practicing those long conversions. A lot of this is, for most people, is much easier than the conversions. Just keep going back over those problems so you don't forget them for the test. Have a good week. I'm sure a lot of you have kids on fall break. Hopefully you get to enjoy a little time with them. Anything else? Thanks for hanging in there for that last question. See ya.